in 9.5 variation, we're going to be relating quantities together based on direct, joint, or inverse variation. So for direct, it's a relationship between two variables. Generally, it's x and y, but those can change. And it can be written as y equals k times x. So y equals kx. In that instance, this value of k, it cannot be 0. If it was, then your x would go away and then we wouldn't have that direct relationship. And that variable k is special, okay? That variable k is called the constant of variation. So this is called the constant of variation. So we know when something is constant, it does not change. Okay, so this direct variation, I want you to just write that in this box here, y equals kx. That way you can quickly refer back to it. So direct is y equals kx. Okay, when y varies directly as x. Okay, so this would be the equation if y varies directly as x. Okay, and I want you to write that in there because our variables are going to change. So in this case, y varies directly as x. We're going to start with the y equals. You're always going to have k, and then x is going to be your other variable. Okay, now this equation is a linear equation. It is in the form y equals mx plus b. So anytime it is linear, think about what your slope's going to be. Okay, this is the form we're used to seeing. So what's in place of your slope here? What's our slope variable? Yeah, the slope variable is k. See how it's in front of the x? That's how you know that it's the slope. And your y-intercept, there's nothing added on the outside, which means our y-intercept is 0. Yep, there's no y-intercept. It's 0. Well, it is actually 0. 0, 0. For this, yes. Yep, always 0. Okay, now for joint variation, this is when you have more than one variable. Okay, and this one, it tells you how it varies. So you can see here it says if y varies blank. So this one is going to be, bless you, this one is if y varies jointly as x and z, it can be written as, and I do think it's important to pay attention to the way this is written. So y varies jointly as x and z. It can be written as y equals, and then you always have your value of k. So it's k times x times z. Okay, that's what I want you to write in this box here. Y equals k times x times z. So anytime it's jointly, you're going to have two variables with that direct relationship. Okay, and we still have that variable k that represents the constant. Okay, so that does not change. Okay, I do think that highlighters help in this section, so feel free to get yours. The first thing we're going to pay attention to is the way that it says it varies. So this says x varies directly as y. X varies directly as y. So the first thing we're going to do is write the equation. So in our example, this said y varies directly as x. So see how we started with y equals? But this one says x varies directly. So we're, instead of starting with y, we're going to start with what? X. Okay, so x equals, and then it's going to be k times y. So that's going to be your equation. Okay, now they're asking you to find x when y is 8. Okay, and then they give you one more piece of information. Y equals 6.5 when x is 13. What we have to do is use this pair to solve for k. So our first step is always going to be to find k. All right, so for finding k, we're going to plug in 13 for x. We're going to plug in 6.5 for y. Okay, and a lot of this we're going to do without our calculator. So we're going to talk about some of those strategies for dividing without your calculator. So it's 13 divided by 6.5. What's the relationship between those two? Yeah, 6.5 is half of that. So if you do 13 divided by 16.5, what do you get? 2. Great. So once you know that this is your value for k, what you're going to do is write what is called the variation equation. Okay, so this is something I'm going to ask you to do on your assignment. Your variation equation is what you wrote here, except with k plugged in. Okay, so it's x equals 2y. Okay, that's your variation equation. X equals 2y. Then we're going to do the next part. So it says find x when y is 8. So we're just going to take this equation, x equals 2y, and we're going to find x when we plug in 8 for y. Okay, so what is your value for x going to be? 16. Okay, so the two things I want to be able to see, I want to see your variation equation, and I want to see x equals 16. Okay, so based on that, I want you to try part B. It is set up a little bit differently, so see if you can highlight. And then I'll come around so I can kind of see how we're doing. Okay, so your first step, and I would either highlight or underline, okay, if it says y varies directly as x. Lorelai, can you give me the equation for that one? Yep, y equals kx. So that's going to be the first thing. So it's not the exact same as this because of the wording, okay? So y varies directly as x. Okay, now we're going to find our k. Okay, so see here it said find x first when y is 8. Now they asked you that second, find y when x is 11. Well, you can only do that if you know k, and we are going to find that value using y is 35 and x is 7. So you're looking for the pair, the y and the x, in order to plug those in. So 35 equals k times 7. So if you divide by 7, what's your value for k? 5. Okay, so then your variation equation remember, is the exact same thing except you substitute k. So y equals 5x. And that's what you're going to use in step 2. So find y when x is 11. Okay, so it would just be 5 times 11, and y would be 55. Okay, any questions for me at this point? All right, then let's try example 2. So it says, if A varies jointly as B and C. So this was our joint variation equation. Y varied jointly as X and Z. So if A varies jointly as B and C, do you guys think you can write down what that equation would be, that first step? Thumbs up if you're feeling good about that. I see 2 thumbs, which concerns me. Okay, all right. Everybody is. Well, most people. Most people. All right, so let's check this. So A varies directly, and then K times B times C. Okay, and then it says find A when. So they're always going to have find a variable, and they're going to give you another variable or variables. And then somewhere there's going to be a pair or a trio that you're going to have to use. So in this case, we have this trio, the A, the B, and the C. That's what you use first in order to find the value of K. And this is going to be your setup. So negative 108. Okay, B is 2, C is 9. So we know that's 18, and you can divide by 18. But if you're doing this without a calculator, okay, you may like just leaving it as divided by 2 times 9. Because then you can just divide. What's negative 108 divided by 2? Yep, so this is just negative 54 over 9. And what's that? Negative 6. Okay, you could also just keep reducing. That would be fine as well. Yep, so you're just dividing. Okay, so I'm just showing you a different way to divide without your calculator. And then for this one, again, I'm going to write out what your variation equation is. Okay, so it's going to be A equals, and then you plug in negative 6, BC. That is your variation equation. So then that's what you're going to use to find A when B is 4 and C is negative 3. You can multiply those in any order. If you're doing this with a calculator, do what is ever easier for you to do without a calculator. For me, I would do 6 times 4 is 24, and then what's 24 times 3? 72. Because, right, how many hours are there in a day? How many hours are there in a day? 24, so 3 days is 72 hours, and then negative times negative would be a positive. So sometimes I try to find those connections. All right, and then why don't you guys go ahead and do B? I know some of you may have started that already. All right, Jackson, will you tell me what you got for your equation? Yep. Okay, so that is your form. Y varies jointly as X and Z. Okay, now this time they gave you the trio up front. Y is 18 when X is 2 and Z is 3. Okay, and then Jack, what'd you get for your value of K? Good. Okay, so 2 times 3 is 6. Divide by 6, you get K is going to be 3. Okay, and then once you find that, you can write your variation equation. Y equals 3xz. All right, and then your second step is to find y when x is -1 and z is 7. Okay, Alex, whenever you have that, let me know what you got, okay? Great, yeah, y equals -21. All right, how are we feeling about that? Not too bad? Okay, the other type is inverse variation. So we have direct variation, joint variation, okay, and then we're going to talk about inverse variation, okay, and inverse variation is going to be the relationship between two variables, okay, where y varies inversely as x. Okay, so y varies inversely as x. That is represented by the equation y equals k over x. And that's what we're going to put in this box here. Y equals k over x. Okay, I put these boxes in there for a quick reference for you so you didn't have to search through these words. But in this situation, you can't have x be 0 because that's the denominator. And then this one gives you a little extra fact that you can use to help you solve. So it should say two quantities are related by inverse variation if their product is equal to the constant. Okay, so let's change this. So it should say two quantities are related by inverse variation if their product is equal to the constant. So what that means is if you can multiply x times y and it equals k, it's going to be inverse variation. Okay, why is that true? Well, if you were to take your inverse variation and solve it for k, what would you do to both sides? Yeah, multiply by x. So if you multiply both sides by x, see how you would end up with k equals x times y? That's why that holds true. Okay? So I'm going to show you how you can use that in these, but really you can just pick one method and stick with it. All right, so in example 3, it says if f varies inversely as g. Okay, if f varies inversely as g. So right away, I can set this up as f equals k over g. And then from there, it says find f when g is -6. Okay, and then it also tells me that f is 15 when g is 9. Okay, f is 15 when g is 9. Okay, so in my first step, I'm going to substitute in 15 and 9. Okay, yes, I'm going to multiply those without my calculator because we have strategies, right? Okay, so 9 times 15, we can just do what's 9 times 10? 90. What's 9 times 5? 45. Add them together. 135. Okay, that's your value for k. So if that's your value for k, your variation equation is f equals 135 over g. Okay, that's the equation. Okay, this is something that you will need to write out on your homework. You will be asked to write it out on your quiz. Okay, so then in step 2, you're going to find f, okay, when g is -6. Okay, and you can either like reduce this or you can use long division. Okay, either way is fine. We just did some long division, right? Okay, 6 goes into 13 how many times? 2. Bring down the 5. Okay, it goes in there twice. Okay, and then when there's nothing to pull down, remember, you can just make a decimal. So bring down the 0. Does 6 go into 30? Yep, 5 times, so it's 22.5. Okay, -22.5. Okay, if you wanted to, this is another method you could use. I'm just gonna exit off here. So you can use this equation, or if you want to use xy equals k, okay, in this case, you could use fg equals k to find it. So if you know k is 135, it says find f when g is -6. This is just another way you could set it up. Okay, you'd end up with something similar. Okay, but that's another way you can do that. Okay, so this is method 2 for step 2. All right, I'm going to have you guys do part B, and then we'll check ours together, okay? So go ahead and set that up. All right, and then Royal, when you have K, let me know what you got, okay?
4.
Yes. Okay, so if Y is 2 and X is 2, we just multiply both sides by 2. Okay, so your variation equation, Y equals 4 over X. Okay, you have to find Y when X is 1. So if you do that, 4 over 1 is just what? 4. Okay, so that's going to be your final answer. Okay. And then again, if you want to do method 2, you would just have 4 equals X times Y. So 4 would equal 1 times Y, and you get the same thing. Okay, so either one of those. Okay. In example 4, you have to state whether the equation represents a direct, joint, or inverse variation for the given variable, and then you're going to name the constant of variation. So you have to find what form this is. So we have y equals 0.2d and then the semicolon y. So we want to figure out how y varies, and we're going to write that down. So we would say y varies, and then look at your other variable. Does it vary directly, inversely, or jointly? Directly. You know it's not inversely because there would be division, right? Okay, and it's not jointly because you would need another variable. So y varies directly with d is what you would say first, and then you have to identify the value of k. Can you guys see this is in the form y equals k of x? Oh, it's like k times d. So your k value is what? Yeah, 0.2. Okay, so based on that, can you guys do part B? So they give you the equation. This z is not part of the equation. You're going to say z varies and then see if you can fill that in. Okay, how does z vary? Right, Caleb, how does z vary? Directly, jointly, or inversely? Yep, so if there's two variables, I just feel like that's a clear giveaway, right? You have two different variables here. Okay, so z equals k times x times y. So z varies jointly with x and y. Okay, and our k value is going to be 1/3. All right, so when you have combined variation, that's the last type we're going to look at. Combined variation is just a combination of two types, directly and or inversely. Okay, so if you have combined variation, that occurs when one quantity varies directly and or inversely as two other quantities. Okay, so this says, suppose A varies directly as B and A varies inversely as C. Okay, we're just going to split this up and focus on one at a time. Okay, so if A varies directly as B, we would start off by saying A equals K times B. What's different about this one is now it says an inversely as C. So we just have to divide by C. Okay, so now we can find B when given the values of A and C. It says if B is equal to 6, when C is 4 and A is 96. Okay, so we're going to plug those in. Okay, so whatever one it tells you to find, we're not using those yet. You're going to use this trio. Okay, so it says A is 96, B is 6, okay, and C is 4. Okay, and you can multiply this by 4 and you can divide by 6, but we're doing these problems without a calculator, so we really want to do what's easiest for us using mental math. So can you guys see this as a fraction 6/4? Yeah, if you reduce that, what would it be? Yeah, so you have 3k over 2. Divide by 2, divide by 2, you have 3/2 k. You guys with me on that part? Okay, then all you'd have to do is multiply by 2, divide by 3, or you can multiply by 2/3. What do you guys like better? You like to do the times 2, then divide by 3? Okay. Okay, so if you're doing 2 times 96, what's 2 times 90? 180. And then 2 times 6? 12. So when you add them together, you get 192. Okay, and then I'm going to divide by 3 to get my value of k. Now, I know 3 goes into there evenly because 1 plus 9 plus 2 is 12. So how many times does 3 go into 19 without going over? 6 with 1 left over. So that 1 goes in front of the 2. How many times does 3 go into 12? 4. Okay, so that's your value for k. So if that's your value for k, your variation equation is A equals 64 B over C. Okay, and now we're ready for step 2. So it says find B when A is 2.5. So I gotta find B. C is 18. Okay, this is another one where if you wanted to reduce first, you could, or you could just multiply by 18 and then reduce. I did multiply by 18 because if I have a double digit number, I can do, well, let's just do 18 times 2. What's 18 times 2? Yep. And then what's 18 times a half? 9. So 36 plus 9, 45. Okay, so if we're not using a calculator, we're just going to keep this as a fraction, reduced. But 45, 9 goes in there, 5 goes in there, 3 goes in there, 64, 2, 4, 8. They are not going to have any common factors, so this is going to be your final answer. Okay, so that is your value for B. That is your reduced fraction. Okay, now we can take these and we can apply them to different applications. Okay, so we're gonna do one of these applications today, and then we'll continue with some of them tomorrow. So this one says the perimeter of a regular dodecagon. You guys remember what a dodecagon is? 12. Yep, because decagon's 10, so the dodecagon is 12. Right? Ooh, 3D. So the perimeter varies directly as the side length S. So right away, once I have that, I like to go ahead and write down what my equation is going to be. So the perimeter varies directly as the side length S, so it's K times S. Okay, and they tell you to find S when the perimeter is 75 inches. Now, all of these are going to have units. So your answer for these does have to include the units, and that's something that I will be looking for on the quiz. Okay, so it's definitely something we want to practice. So P is 18 when S is 1.5. Okay, so our first step is always find that value of K. So if the P is 18, okay, and the S is 1.5, okay, you are dividing by 1.5, but if you're doing that without a calculator, what's 1.5 as a fraction? 3/2. So if you have 18 divided by 3/2, you could keep change flip. Okay, what's 18 times 2? 36. 36 divided by 3? 12. So your K value is 12. All right, which means your variation equation is going to be P equals 12S. Okay, and then we can use that to find S when the perimeter is 75. Okay, so you have 75 equals, oops, I put an equals here. Change that into 100. All right, so 75 is equal to 12S. So we are just going to divide by 12. So 12 does not go into 75 equally. We're going to write this as a fraction. How many times does 12 go into 75 without going over? 6, because what's 12 times 6? 72. So if it goes in there 72 times, remember how you can write the remainder over the fraction? So 75 minus 72 is 3, so it's 3/12. And what does that reduce to? 1/4. Yep, so your S is going to be 6.25. Now, on the story problems, again, you have to make sure you include your units. Okay, on the story problems, some of them are going to be calculators, some of them are going to be no calculator. Okay, so one like this we could do without a calculator, but let's do one where we have to find a where we have to use a calculator, and then we'll stop there. Okay? Okay, so you guys may or may not remember this formula. The lateral surface area of a cone varies jointly as the base radius r and the slant height L. So remember you have that fancy L for the slant height? Okay, and it says an L is, and we're going to fill that in. So this would be given to you. So it'd be 63 pi meters squared. Okay, so that's your lateral area when the R is 3.5 meters and the slant height is 18 meters. You're going to find R to the nearest tenth. And actually, this is one where we can actually do this without a calculator. They wouldn't have gave us that direction, but they did. So the L is the 8 pi meters squared. So they're telling us to round to the nearest tenth. So that lets us know we need a calculator. But this one actually turns out pretty nicely. So you're finding R when they give you 8 pi is L, and the slant height is your 5 meters. So we always start off with that equation. Okay, the equation for this would be L equals, and then remember, you always need your K. It varies jointly as the radius R and the slant height L. So it's just times R and then L. Any questions for me on setting up the equation part? All right, and then we're going to find K. So when you're finding K, they give you here that L is 63 pi. Okay, don't put the units when you're solving because that just looks too messy. We are going to need them for the last step. So they give you R is 3.5 and they give you L is 18. And it really will be nice to have a calculator for this step, but I want you to see what happens. Okay, so when we take 18 and we multiply it by 3.5, what do you get? 63. So that means you are dividing both sides by 63, so your answer for K should be pi. Leave K as an exact value. And then you'll see this is the real formula that you guys used in geometry. Pi times R times L, your slant height. Okay? All right. So you do want to leave that as an exact value. Okay, so then step 2, we're going to take L equals pi R slant height. Okay, and it tells you the lateral area is 8 pi. Okay, we have to find R, and then the slant height in this case is 5 meters. So what would I want to divide both sides by if I'm solving for R? Pi and 5. So we can do both at the same time. Okay, the pi will cancel out with the pi, the 5 cancels out with the 5. And then here the pi's cancel. So when I say, oh, it turned out nicely, this is what I mean. So you have 5 times pi, so we're just going to divide them both. And then here, so your R, you could leave it as 8/5 if it didn't tell you to round, but it does. So we're going to divide. It says round it to the nearest tenth, and then you have to include your units. So when you're deciding what units to include, you have m squared, and you have meters, and you have m. You can look and see what the R is. So R is 3.5 meters. Okay, you can either write out meters or you can just put m, but you need to have your units. Okay, so that's something that I will look for on the assessment, okay, is that you have your units included. Okay, so for 9.5, you can get a surprisingly decent amount of this done in 15 minutes. Okay, I saw it done earlier today.